having technical difficulties. I don't know where this video stopped at, but I'm going to start it over again. This video is on the natural log function of integration with trig functions. Up until now, we knew how to find the integral of trig functions if they went directly back to the derivatives that we know of. Well, now I've included a list of the basic trig integration formulas, such as the integral of secant u, the integral of cotangent u, the integral of cosecant u, and of course the integral of tangent u. I've also included the ones that we've already studied before. So let's do some examples now. So for example 1, we're going to use u substitution. We're going to let u equal to 3 theta. du is going to equal to 3 d theta. Divide by 3, divide by 3. Rewrite our integral as cotangent u times du over 3. Pull out our constant. And then integrate, which would give us 1/3 ln of sine of u, and u in this case is 3 theta, plus c. For example B, we don't need to use u substitution, we can just integrate automatically, which would then give us theta cubed over 3 minus tangent theta plus c. For our next two examples, we're going to use u substitution. U is equal to 2 minus 3 cosine theta. Du is going to equal to 3 sine theta d theta. Divide by 3, divide by 3. Rewrite it as 1 over u times du over 3. Pull out the constant, 1 over u du, and integrate it would give us 1/3 ln of u, which in this case is 2 minus 3 cosine theta plus c. U will equal to 1 plus sine of t. Du will equal to cosine of t dt. We don't have to divide by anything. We rewrite it 1 over u du, which then equals to ln of u, which was 1 plus sine t plus c. For example 2, we now have definite integrals, but we're still going to be using u substitution. So u is equal to, before we do that, if we remember our Pythagorean identities, this here is the same thing as cosine squared of t, because sine squared plus cosine squared is equal to 1. So if we evaluate this, we have the square root of cosine squared t, which is the same thing as just cos of t. So we're going to have from 0 to pi over 2 of cosine of t dt. We don't need to use u substitution on this one. We simply integrate it, which would give us sine of t, evaluate it from 0 to pi over 2. Sine of pi over 2 is 1, minus sine of 0 is 0, so that gives us a solution of 1. For this next one, we are going to use u substitution. X plus cos of x. Du would be 1 minus sine of x. But we can change our limits. Cosine of pi over 2 is 0, plus pi over 2 will remain pi over 2. 0 plus cosine of 0 is 1, so that'll change our limit to 1. So we're going to go from 1 to pi over 2 of 1 over u du, and that'll give us ln of u, evaluated from 1 to pi over 2. We don't replace u here because we've changed our limits already. So we evaluate straight through. Ln of pi over 2 minus ln of 1, which is 0, so our solution is just ln of pi over 2. For example 3, we're asked to solve the differential equation that satisfies the given point. So first we're going to send d theta to the right side. So ds is going to equal to tan 2 theta d theta. Then we're going to integrate both sides. The left side, remember that integrals and derivatives will cancel each other out, so it'll give me just s is equal to, we're going to use u substitution. U will be 2 theta, du would be 2 d theta, divide by 2, divide by 2. We'll have the integral of tan u times du over 2. Pull out the constant, we'll have 1 over 2, negative 1 over 2, ln of cosine of u, which was 2 theta, plus c. We replace our points, so that's s, this one's s, this one's theta, so that we can solve for c. So 2 is equal to negative 1/2 ln of 2 times 0 is 0, so cosine of 0 plus c. Cosine of 0 is 1, but the natural log of 1 is 0, so this whole portion becomes 0. So we have 2 is equal to c, so our final solution is s is equal to negative 1 over 2 ln of cosine of 2 theta plus 2. For part B of example 3, I've given you the solution and I want you to work that one out on your own, following the same process as part A. For the last example, we're asked to use the mean value theorem to find the value of c for the given function and interval. So if we integrate this, that's going to give us sine of x, and we need to evaluate it from negative pi over 3 to positive pi over 3. So that gives us sine of pi over 3 is square root of 3 over 2, minus sine of negative pi over 3 is negative square root of 3 over 2, which would then simplify to 2 square root of 3 over 2, which then simplifies to the square root of 3. For our next step, we're going to find our average value, which is essentially our average height. And what we do is we take the value that we found and we divide it by b minus a. So square root of 3 over pi over 3 minus negative pi over 3 is the same thing as 2 pi over 3, which is approximately 0.8269. For our next step, we're going to take our average height, which we found, and set it equal to our function to solve for c. So we're going to take, and I'm going to take the exact one, simplify that becomes 3 square root of 3 over 2 pi, set it equal to cosine of c, and to solve for c, I got to do the inverse of cosine. So cosine of minus 1, 3 square root of 3 over 2 pi, equal to cosine inverse and cosine will cancel each other out, so that'll give us c, which is now approximately 0.5971, and this is our average width. Now if we sketched it out, it would look something like this drawing here, and given our average height and our average width values, those would give us the rectangle underneath the curve within that interval that would give us the most approximate solution to the area underneath the curve. I hope this video has helped, and I shall see you soon.